So next we're going to take a look at page 73 of your handbook. And you can actually pause right now and take some time to look at all 10 of these questions and try and figure out why you think they are wrong. They have all big X's through them, so all of them are incorrect. And so for each of them, I want you to think about explaining what the student did wrong and then explain how to correct their work. So you should pause it right now and then come back after trying them all. Now that you've tried them all, we're going to look through these together. Now, one thing to keep in mind is, yes, there are exponent rules that you could kind of have memorized. And if you worked in ALEX, it might have tried to have you memorize some things. But if you just think about the meaning of exponents, you'll be able to work through all of these. So for the first one, we're looking at 2 to the 5th equaling 10. That's a really common mistake. But this is impossible because 2 to the 5th really means 2 times 2 times 2 times 2, 5 of them, which is actually 32. So the student just multiplied 2 times 5, which does equal 10, but that's not the meaning of the exponent. This is the actual meaning. When you look at question number 2, they have negative 2 to the 3rd equals 8. So they didn't just do 2 times 3, but they forgot about this negative. So our base here to the 3rd power is negative 2. So we have to write negative 2 times negative 2 times negative 2. But when you have a negative multiplied an odd number of times, it's still negative. So we're going to have negative 8. So their error was that they missed the negative, but you can see that it is needed. On question number 3, so that looks slightly different from question number 2, its base here is only the 6. So I think that they tried to take, it looks like, negative 6 times negative 6. That's the only way to get that positive 36. But what this actually means is negative, or take the opposite of, 6 times 6, because it said 6 twice. But then that ends up being negative 36. So you can see the difference here. If there's parentheses, then you can see that's what your base is. If there's not parentheses, you can see that our base has to be the 6 and the 6. All right, for question number 4, it looks like they just removed the parentheses, kind of. But what 5x, this is your whole entire base, 5x, it has that power 2 on it, so that means 5x times 5x. And that would end up being 25x squared. So it looks like they forgot to take that power to that 5. And again, it's because it was in parentheses. That was our whole base. For number 5, let's see. At first glance, it just looks like they took a 3 and a 4 and then said that was 7. But let's look at what the exponent means, because I think it has to be more than that. Because y to the 3rd, it wants us to write that 4 times. That's a lot of y's. Because you have 3 y's, another 3 y's, another 3 y's, another 3 y's. If I wrote all of that out, I'd actually have 3 times 4. I'd have 12 y's sitting there. So there's no way that it could just be the 7. So I think the mistake that they made is they just added the 3 and 4 together, but they were actually supposed to multiply, because you can see we have 3 y's 4 times, so 4 times 3. That's why we had to get 12. So some of you guys might know that a power raised to another power, we have to multiply the exponents together. So that's an exponent rule. All right. So if I scooch over to number 6, just looking at the numbers I got going on, I see a 12 and a 4 and 3. It looks like just 12 divided by 4. But if you think about what exponents again mean, we have like 12 x's on the top. And then there's 4 on the bottom. And so we've kind of already seen this before, but 4 of these will reduce with 4 of those. The exponent rule really says that if you have a to the m over a to the n, you're going to have to subtract the exponents, which we used previously. But again, you can see why it's subtraction, because they're canceling each other out. So then this leaves actually x to the 8th power. So again, you're not just dividing these numbers, even though it is a division problem, you're thinking that you're dividing out by 4 x's, which leaves x to the 8th. For number 7 here, it looks, again, like they just took the 2 to the x, which you know it has to go to the 5 as well. And then this time we have a fraction, so that 3 doesn't multiply by 2. It has to be written that many times. So again, the meaning of that exponent is saying this is my base, and I need to write it twice. So this will be 5x over 3 times 5x over 3. And so you can see on the bottom, it's not going to make 6 because we have to multiply those. That's 9. And we do have x squared, so that part was correct, but they didn't take it with the 5, so that has to be 25. All right, on number 8, again, this is a common error, but if you think about how exponents work and what they mean, you'll never make this mistake. Okay, it says we're going to multiply. So I see that the mistake they made is they said 2 times 3 is 6. But that's not what the exponents mean. X squared means x times x. X to the third means x times x times x. So if you look at how many x's we have written down here, it's only 5 x's. So what happens when we're just multiplying is that if you have a to the m times a to the n, then all that this means is you have m a's and n a's, and so altogether you would have m plus n a's. So that would be the exponent rule there. For number 9, we talked about this earlier, that a 0 exponent, remember any number to the 0 power, that's when we're dividing by the same thing that's on top. So we end up getting 1. But if you look at our base here is this 10x squared. So if we take it to the 0 power, well, it has to be 1. Never will we get a 0 as a result from an exponent. All right, and the last one on this page, we have the -2. It looks like they just put the 2 on the bottom, but that doesn't make sense because the 2 is just telling me how many x's that I have. So this is my base. So I know I have 2 of them, and now the negative is just saying that they live on the bottom or you're dividing it out. Sometimes you might see the word reciprocal, so it's just 1 over x to the 2nd power. So they have the idea of reciprocal, but it's taking it to the base number. So 1 over x squared would be the correct answer. All right, when you flip the page over to page 74, you're going to work on simplifying a whole bunch of expressions. Again, you can just use the meaning of exponents. So you should pause it and try before you finish watching this video. And so now that you have paused it and you're back, we're going to go through these together. So we have 15 questions here. All right. So 1 and 2 look very similar, except the number 1 does not have a parenthesis. So that means the power is only on the 3. So we're going to take the opposite of 3 times 3. So that will be a -9. Compared to number 2, that means you're going to take -3 twice, which will end up with a +9. On number 3, they want us to take -3 3 times, which will end up being a negative, and we'll get 27 out of that. For number 4, we're looking at the base is only x squared. So if we have x squared written out 5 times, that's going to be a total of 10 x's. So we're going to get the number 3 and then x to the 10th power. On number 5, our base is that whole 3x squared. So you're writing that whole thing 5 times. So this is a little different because now you're going to have that 3 written out 5 times. And again, you don't have to actually write this out. You can just kind of think about it. But because we're newer to some of this, it might be nice. So 3 times 3 times 3 times 3 times 3, that's really 3 to the 5th power. And we'll have x to the 10th. And 3 to the 5th power is 243. So I'll have 243 x to the 10th power. For number 6, we have this entire base to the 0 power, and we have been learning about 0 exponents. That will all just be a 1. For number 5, even though there's parentheses, we don't have any powers outside of them, so we really just have 5y to the 4th times 3y squared. We can rearrange that. It's a commutative property. And so we already know 5 times 3 is 15, and if we have 4 y's and 2 y's multiplied, that's a total of 6 y's being multiplied. And we're going to do the same thing on number 8. So really the -8 and -9 can multiply to make -72. Then we have one m here and two m's here, so that's a total of 3 m's being multiplied. And then we have n to the 6th and n squared, so that's a total of n to the 8th if you were to write them all out. On number 9, now we have a power, so that means we're going to have 2 of that first parenthesis since that's the whole base. And we still have the 7a to the 19th b. So we could rearrange these, but really it's just the number parts can multiply. So we're going to have negative 7 times 7, negative 7 times 7. So we're going to get a positive 343. And then the a, well, we have 3 a's here times 3 a's here times 19 here. So we have 3 and then another 3, that's 6. And then 19, that's going to be a to the 25. And then b's, we have 3 here, that's a total of 6. And then another one, that will end up being b to the 7th. Okay, scooting up to the top column. Now we have a fraction, but that's okay. It's just squaring that whole thing. So we're going to have it written twice. So xy to the 4th over z squared. And then we're going to have another one of those. Xy to the 4th over z squared. So in the numerator, you can see you have an x and an x, so that's going to be x squared. A y4 and a y4, that's altogether 8 y's. On the bottom, 2 z's and 2 z's, so we have z to the 4th. And if you look at the exponent rule, it's like this 2 is kind of coming in and multiplying with each power. So then on the next one, we have that fraction written out really 4 times. So I know the negative will go away. So really let's just look at 2x z to the 3rd over z squared. You can write it out 4 times. You can also just think about what would happen if you have 4 of each of these things. 2x z to the 3rd, z squared. So what I mean is I know that I have the number 2 and it's going to be written out 4 times like you see. And when we multiply that, that's going to be equal to 16. Then x is written out 4 times. That will be, well, x to the 4th, which you could see. And then the z's, we have 3 of them written out 4 times. Well, that's going to be a total of 12 z's. And then on the bottom, we have, oh, there's these. We could have actually simplified. Now I'm looking at it. These z's could have simplified before we started. But since we have it like this, it's fine. So we have 2 of them, and that's 4 times. So that's going to be a total of 16. And so this isn't considered simplified yet because we have the same base in more than one place. So we have 16 on the bottom and 12 on the top. So then we're going to be able to reduce all 12 of these will cancel out. And you'll be left with only 4 on the bottom. So that'll be z to the 4th. And then we have 16 x to the 4th as our final answer. And again, the other way you could have done it is simplified in the beginning. So we have negative 2x, the z3, z2 would just become a z on the top. And we could write that out. Four times. So that would be the negative 2 4 times, which is positive 2, which would be 16, x to the 4th, z to the 4th. And as I'm writing that, I'm trying to see there was an error over here. Oh, oopsie. So hold on, let's fix it. This z to the 16th shouldn't have been 16 because it was 2 of them and 2 of them, 2 of them, 2 of them. That's only a total of 8. Okay, so let's cross that off. A little mistake going on here. So look, it's 16x to the 4th, z to the 12 over z to the 8 is what it should have been. So now there's 12 on top and 8 on the bottom, so it's actually all 8 of those that would cancel. And so that will leave 16x to the 4th, z to the 4th, yay, which matches when we did it the other way too. So sorry about that. All right, let's see if we can get through these next ones without a mistake. Let's see, we have, there's a lot of x's going on. So x12 over x5, that's total of 12 x's and then 5 on the bottom. 5 of them will cancel, leaving us with 7 x's on the top. And then y's, we have 13 on the top and 7 on the bottom. Again, 7 will cancel out. We'll be left with y to the 6th. On number 13, we have some negative exponents going on. So right away when I see that, I want to do that reciprocal or divide by it. Now when there's a negative in the bottom and you divide by it, that actually moves it to the top. So this will be rewritten 2a to the third b squared. I'm going to write this a to the negative 1 on the top. On the bottom then, I'm just going to have the b to the fifth c, but this c to the negative 1, I'm going to move to the bottom. So it'll become c to the positive 1. So as soon as you move it, when you do that reciprocal, that's what that negative exponent means. So now we have positive exponents going on. So then this will become, on the top, I have 2, but there's an a3 and an a. That's a total of 4 a's together. And then b squared still sitting there. On the bottom, I have b to the fifth and a c and then c to the 1. That's just going to be 2 c's. And then this isn't completely simplified because I have the same base in 2 places. So if I have 5 b's here and 2 here, I'll be able to cancel out those 2, but then I would have 3 b's on the bottom. And that would be my final answer. All right, for number 14, there's kind of 2 ways to do it. As soon as I see that negative exponent, though, it makes me want to divide. So I'd have 1 over x to the fifth to the positive 1 power, but really that's just 1 over x to the fifth. You could use the power to a power rule and say this is x to the negative 5, but that would still be 1 over x to the fifth. So however you want to think about that. So for number 15, we have this x to the negative 1 and y here to the negative 3. We can divide by those, so it will be 10, y to the fifth still hanging out, but x to the negative 1 will come to the bottom, y to the negative 3 will come to the bottom. And so then this will simplify a little more because these are the same base. So if I have 5 on the top, 3 on the bottom, those 3 will cancel out, and I'll have 2 left on top. And 10 still hanging out there, and then we have just rewrite x. And that would be my final. If you want some more practice, you can check out pages 75 and 76, but that's all we're going to have for now.